Okay, now I show you several homework problem solving. Question 7. A. What is the wavelength in nanometers of light having frequency 80.6 times 10 to the 13th power hertz? Here is the wavelength, here is the frequency of the light. 8.6 times 10 to the 13th power hertz. After you calculate wavelength. So wavelength times frequency equal to C. So wavelength should equal to C divided by frequency, nu. And C is light speed, 3.0 times 10 to the 8th power meter per second. During the quiz or test, I will provide you this number. And the frequency is 8.6 times 10 to the 13th power hertz. Hertz actually means per second, so cancel per second and left over meter. So use your calculator. 3 divided by 8.6 in your calculator will be 0.349. Exponent division is minus, so 8 minus 13 is -5. -5, but here is less than 1, so we need to use 1. So 3.49 times, you use the 1, you need a -1. So -5 minus 1 is -6. Unit is meter, as I said, per second cancels the hertz. So unit becomes meter. And here also in nanometer, then nanometer, meter, you want a nanometer, you don't want a meter. So nanometer in top, meter in bottom. Nano is 10 to the -9 meter. So meter cancel the leftover nanometer. Divided by 10 to the -9, then just plus 9. Plus 9 is 9 minus 3, 6 is 3. So your answer will be 3.9 times 10 to the 3rd power nanometer. And B, what is the frequency in hertz of light having wavelength 566 nanometer? So this time, here your wavelength is 566 nanometer. Also, you calculate wavelength or frequency. So we just switch this frequency with wavelength. So frequency should equal to C divided by wavelength. Because C equal to wavelength times frequency. All right. So wavelength, the frequency equal to C divided by wavelength. So C is light speed, is 3 times 10 to the 8th power meter per second. As I said, I will provide you this number during the quiz or test. And the wavelength is 566 nanometer. So you need to be careful. This is a nanometer and this is a meter. You cannot cancel this. So you need to convert a nanometer into meter. 1 nanometer, 10 to the -9th power meter. So nanometer cancel, the meter cancel this meter. Leftover per second, which is hertz, is a unit for frequency. Then use your calculator. 3 divided by 566. Put this in your calculator. This should be 0.053. Exponent, don't put it in the calculator. So 8 minus 9 minus -9. So division is minus. So 8 minus -9. which is 17. And here, much less than 1, so we need to use 2 decimal places. Move 2 decimal places, then reduce 2 from here. 8 minus -9 is 17. Then reduce 2. 17 reduce 2 is 15. Actually here, main mistake. This is 0.005. 0053. Not 05. So we need to use 1, 2, 3. 3 decimal places. Reduce 3 here. So this will be 40. Okay. Left over per second, which is hertz. This is question 7. Next. Next question is next question, let's say 29. Consider the following energy level of a hypothetical atom. E4 is -1 times 10 to the -19th power joule. E3 -5 times 10 to the -19th power joule. This is question 29. E2 -10 times 10 to the -19th power joule. E1 -15 times 10 to the -19th power joule. Now A asks you what is the wavelength of the photon needed to excite an electron from E1 to E4. So electron initially in E1 want to promote it to E4. So we need to shoot light on it. Ask you what is the wavelength of this light? Light consists of a photon. Right? So clearly, the energy needed from the light is the energy difference between E4 and E1. Excited E1, electron from E1 level to E4 level. So the energy needed is the energy difference between these two. So E4 is -1 times 10 to the -19th power. And E1 is -15 times 10 to the -19th power joule. So the difference is 14 times 10 to the -19th power joule. So this is the energy needed for the photon. And here also is the wavelength of the photon. So wavelength linked with frequency linked with energy directly, and frequency linked with wavelength. Similar as from question 7, right? Because wavelength times frequency always equal to C. Then frequency equal to C divided by wavelength lambda, right? Then H is Planck constant, 6 times 6.3. No, we need to solve for frequency, for wavelength. So E equal to Hc over lambda, then lambda equal to Hc over E. The H is a Planck constant, 6.643 times 10 to the -34th joule second. And C is light speed, 3 times 10 to 8 to the power meter per second. Planck constant h, light speed c, I will provide you during the quiz or test. E is energy needed. We just calculated as 14 times 10 to the negative 19th power joule. So joule cancel this joule. Second cancel this per second, left over meter. Use calculator is just 6.63 times 3 divided by 14. Regular number put in the calculator, which is 1.42. And exponent, negative 34, multiplication is plus, so negative 34 plus 8. Division is minus, so minus negative 19. Negative 34 plus 8 minus negative 19. So this is negative 7. So 1.24 times 10, 42 times 10 to the negative 7. Unit is meter. And A asks you wavelengths needed for the needed to excite electron from E1 to E2. So you can stop here again because then it specifies this wavelength must be in meter or in nanometer. So if you want, you can convert this into nanometer because 1 nanometer is 10 to the negative 9th power meter. So divided by 10 to the negative 9 is times 10 to the 9. 10 to the negative 9 is minus 72, 2 move to same place. Becomes 142 nanometer. As I said, since here then specify, so you don't have to do this step, just keep in meter is fine. Then B. Ask you what is the energy in joule a photon must have in order to excite an electron from E2 to E3. So this time, electron from E2 to E3. So shoot a light on it, excite the electron from E2 to E3. How much energy needed? So clearly similar as here. Energy needed is the energy difference between these two energy levels. So E3, E2. E3 is the final. E2 is the initial. Equals to 5 times 10 to the negative 19th power joule. Okay. C. When an electron drops from E3 level to E1 level, the atom is said to undergo emission. Calculate the wavelength of the photon emitted in this process. So this time, electron drops from E3 to E1 level. This time, electron drops from E3 to E1 level. First of all, we can calculate the energy will be emitted. So energy equals to energy difference. So E3 to E1, so E1 is the final, E3 is the initial. negative 10 times 10 to the negative 19th power joule. Negative means release energy. So release 10 times 10 to the negative 19th power joule. From the energy released, we can convert it to wavelengths. So energy equal to h nu, and nu equal to c over lambda. So lambda equal to h times c divided by E. H, Planck constant, 6.63 times 10 to the negative 34th power joule second times speed, light speed is 3 times 10 to the 8th meter, 8th power meter per second. And E is the one we just calculated, but only put the absolute value there, because the negative sign only tells you this is release energy. Plus, wavelength or frequency cannot be negative, so don't put a negative sign there. So use your calculator. 6.63 times 3 divided by 10. This is 1.989. Exponent negative 34 plus 8 minus negative 19. This is negative 7. Unit is meter, because joule cancel, second per second cancel, leftover joule meter. Yeah, also you calculate wavelength, then specify must be in meter or nanometer. So you can keep this as your answer. If you want, you can convert it to nanometer. So 1 nanometer equal to 10 to the negative 9 power meter. Then this will be 198 nanometer. You can keep in meter or nanometer if you want. Only if I specified must be nanometer, then you have to convert your answer to nanometer. And plus, I would like to show you one more, not least as a assigned homework. It's about write electron configuration and orbital diagram. Let's say for copper. With the help of periodic table, copper, from periodic table, we know copper have 29 electrons. Then from this charge, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d. This is the order to fill electron in these orbitals. Then we can write electron configuration for almost any electron, for almost any atom. So with the help of periodic table. So copper 29 electrons. So clearly we need to fill 2 in 1s orbital, then fill 2 in 2s orbital, then fill 6 in 2p orbital, because p have 3 orbitals. Each orbital hold 2, and then 3 orbital hold 6. So after here we'll fill in 6. We'll fill in 10. We still have electron. 2p, then 3s, then 3p, 6, Then 4s2. Up to here, we have 20 electron field. After 4s should be 3d, so only 9 left. D maximum can fit in 10, but only 9 left, so 3d9. Whenever you write 3d9, you need to think about becomes 3d10. Pour 1 electron from 4s to 3d. Become 4s1, 3d10. This is the correct electron configuration. This is pour 1 electron from S to 3d10. 3d10 is a full field, right? The full field is more stable. So this is the electron configuration. Then write orbital diagram. 1s, 1 orbital, 2 electron. 2s, 1 orbital, 2 electrons. 2p, 3 orbitals, 6 electrons. 3s also 1 orbital, 2 electrons. 3p, 3 orbitals, 6 electrons. Each orbital fills 2 electrons in opposite spin direction. Then 4s only 1 electron. And 3d, 5 orbitals. 10 electrons, so fill in 2 electrons in each orbitals. Okay, and I would like to show you another one. Let's say nitrogen. How many electrons? So from periodic table, clearly nitrogen 7 electrons. Then we could write 1s2, 2s2, 2p3. Looks very simple, right? Then 1s, 2 electron. 2s, 2 electron. 2p, 3 orbitals, 3 electron. How can we fit 3 electron in 3 orbitals? How does the rule tell you? Fill in 1 electron in each orbital first, and these electrons are in same spin direction, either all clockwise or anti-clockwise. Either way. So either all upward or all downward. Or some book just draw one line instead of a box. Or fine. These two same, right? We change. So you can either use a box that represent one orbital or use a line represent an orbital. But one thing I need to point out is your orbital diagram must align the electron configuration. Without this electron configuration, just draw this box to tell orbital diagram. Nobody can understand what this represent for. This could represent 2s, this is 3s, this is 3p, right? You need the right electron configuration and the orbital diagram align them. Then the other body can understand what this orbital represent for. Okay. So write 1s there, 2s here, and then 2p here, so other body can understand that this square is for 1s, this is for 2s, and this 3 is for 2p. Okay, which everybody can make A in the quiz 7. Let's stop here.